Hello everybody, this is Mr. Mayer, and in this video we will discuss creating reflections on the coordinate plane. So we got two examples. The first one, we need to reflect the trapezoid over y equals -2. And as you can see right here, this is kind of the notation which we are going to use to represent a reflection of the trapezoid over y equals -2. Little r stands for reflect. Y equals -2 in parentheses, below the r. This is the line that it wants you to reflect, and then this is the shape that it wants you to go ahead and use. So what we're going to do first is I want to go back to the lesson and make sure you see where your steps are located. If you look at your block 3 and in our Create Reflections tab, you can notice in the instruction that we have 4 steps. Steps 1 through 4. So step 1, we are going to graph the line of reflection. Step 2, find the distance from each point to the line. Step 3, create the new image. And then step 4, we're going to check your work. So let's go ahead and get started. Step 1 was to graph our line. So it's telling us to reflect over y equals -2. So it's telling me on the y-axis, I want to move down -2. So remember, always label your axes first. This is the x, side to side. This is the y, up and down. So I'm going to go on the y, down 2. So right now, this is where y is down 2. In fact, I want to go on this graph everywhere where we have a -2 in y's place. So you notice we have it right here, we have it right here, we have it right here, and to the right as well, a whole bunch of different points everywhere. So this is the line we are going to create in order to reflect. So go ahead and draw that line. At this point, step 2 states we are going to find the distance from each point to that line. So I'm going to go ahead and look from each point. If I look at Q down to the line, I'm counting 2 spaces. Okay, so it's always counting spaces, not the dashes. If I go from R down to the line, I'm going to count 1, 2, 3, 4 spaces. S to the line, it's up 2, 3, 4, 5. The T is 4 away. So in order to finish this up, now that I've counted each of the distances, I'm going to create my new image. So I'm going to go 2 away from this point. So I'm starting from this point, and to create the new Q, I'm going to go another down 2 in the opposite direction. First, away from the line I went up 2, now I'm going to go down 2. So this is my new Q. I'm going to go ahead and label this as the new Q by putting a apostrophe. The apostrophe is called a prime, Q prime. This is the new image of the pre-image Q. For the S, it was directly above Q. Now it's going to be directly below. So S was 5 up, so it's 5 down from the line. 1, 2, 3, 4, 5. This is my S prime. If I look at R, R was 4 away, so I'm going to go 1, 2, 3, 4 down for my R prime. And then for my T prime, it was 4 up, so now I'm going to go 4 down. 1, 2, 3, and 4. And the last thing is I need to connect all of my new points. So I'm connecting these, and this is going to create my reflection of that trapezoid. Okay, last step was to check our work. Just double check, make sure everything is the same distance. So this was up 5 before. Make sure that this is 5 down. 1, 2, 3, 4, 5. Yep. Make sure that this one. Our next question, we are going to reflect the triangle over the line y equals x. Again, in this notation, it's lowercase r, y equals x. This is the line to reflect it over, and this is the triangle ABC. So to review, make sure you understand, where is this line, y equals x? It's where every y value is equal to every x value. So if y is 0, then x has to be 0. So it's this point right here. Again, I'm trying to make a full line though. So where else could y be equal to x? If y is 1, x could be 1. So it's this point, this point, this point. It's all of these here. Okay? So this is our line that we are trying to reflect over. This is y equals x. Now we have a nice quick little way to reflect these. There's kind of a rule that works when I'm reflecting over only y equals x. It's only true for y equals x. When I reflect over y equals x, the rule is when we reflect, you reverse the ordered pair. So this can be a nice way to check in the end. If you want to see right now, the best way to do this, we cannot count on slants on a graph. On a coordinate plane, you cannot count at a slant. So we have to go either side to side or up and down. So if I go, let's say from A to the line, I'm going to count over. So I'm going ahead, I've already graphed the line. Step 2 is to find the distance from the point, each point to the line. From A to the line is 1, 2, 3, and 4. From B, I can count this way. 1, 2, 3, 4. C, I'm going to count down. 1, 2. So this is kind of confusing. How do I know where to go? Do I go 2 more down? That's going to end up getting us really confused here. This is when this comes into play. If I reverse the ordered pair, this is a great way to start off. So if I look at the original coordinate for A, the original coordinate was -2, +2. So -2 on my x-axis and +2 on my y-axis. So now at this point, I'm going to reverse that ordered pair. Instead of -2, 2, I'm going to flip them and say 2, -2. So if I go ahead and graph that, I'm going to go 2 to the right, down 2, and let's put it this way. This is going to help us understand which way we're going to go. I went 4 to the right before. Now I'm going to end up going 4 down. So we're already checking our work. For the B, I went 4 down before. Which way would make sense to go 4 after I reflected? It's going to have to go 4 to the right. So this is my new B. Let's double check. Use your rule. B was -4, 0. That was the original coordinate. If I flip-flop those, my B prime is going to be 0, -4. Is that the correct coordinate that I've just used? It sure is. I didn't go side to side any on the x. And for the y, I went down 4, so this is perfect. For the C, let's go ahead and use the coordinates, see if you can use your rule. The coordinate for C was -1, 2, and 3. And then down 1, so -1. So if I flip-flop those, I'm going to go left 1, and then I'm going to go down 3. 1, 2, 3. So this should be my new C, my C prime. Let's double check. It was 2 up. If I went 2 over, perfect. So we've already double checked them. Last thing to do is connect these, make yourself your triangle, and now you have your reflection. Alright guys, thanks for tuning in. See you next video.